Hello guys, this is Lanley Solder HMS supporting for solving conservation of linear momentum. Now, for solving this conservation of linear momentum, this is the formula. So, mass multiply the velocity of the first object plus the mass of the second object times its velocity and equals to the same thing. So, I have this sample problems. I'm gonna show you this one. So there are two balls rolling towards each other. One going to the right and the one's going to the left. So I'm right to the left, to the left, to the left, yeah. So to do this, you just have to copy the given things. So 13 multiplied to its velocity of 14 plus, so I'm gonna write this for a while. Now that I have written it, I'm going to show you how conservation of linear momentum works. So conservation of linear momentum is happening during a collision. So this is 100, so this product, this is 182 plus 90. This should be negative because this is going towards the opposite direction. So you should write negative sign in it. So that is how conservation of velocity works. We're going to see if the momentum will be conserved after a collision. So these two balls is just going to glide to each other with no other reason because I just roll it towards each other through a drawing. But now solve it. So 182 minus this negative 90, so sum of it is 92 equals to 92. So as you can see, this is the momentum from before the collision, and this is the momentum after the collision. As you can see, the momentum between them is conserved. So that is how the conservation of linear momentum, and this is the first formula for it, by conserving. Now I'm going to show you a sample problem which will totally show you how it will be conserved. Now using the formula, we are going to find out if the momentum will be conserved. If Tom is playing playing bowling, he rolled the bowling ball towards a bowling pin at rest. The bowling ball has a weight of the bowling pin at rest has a weight of 1.5 kilogram and the bowling ball of 5 kilograms and has a velocity of 3 meters per second. Now my gadget's almost up, but I'm going to make it quick. So now I have copied the given, so ball. So now we're going to use this formula. Actually, there are two classifications of collision. The one is elastic and the one is inelastic. So I'm going to explain it to you. The elastic one means that if the two objects collided, they will bump away to each other. So that is how it explains. But the other one, the inelastic collision, is when they bump to each other, they will stick and share the momentum that they are having right in the collision. So Now let us see if they will or will not stick to each other. So it's a bowling pin. So now to write, I'm just going to write it. So boom. Now that I've written some, I have changed the rule. Now I'm going to find the velocity of the bowling pin after the collision. So it's going to copy this. But the velocity, so I'm going to give this a given. So going to change the final velocity of the bowling ball is 2.1 meters per second. So that's pretty hard to think. The final velocity, so it's still 5, so I'm just going to copy it. 2.1 plus 1.5 and final velocity, so it's VF because it's velocity final. So I'm just going to find out what is the final velocity. So he threw a bowling ball. So this is 15. Clearly this is 0. This is this should be, wait, I'm just solving with should be 10.5 and plus the velocity final. So this is, so should erase this one because it's 0 anyway. So this should be the, so their unit should be kilogram meter per second. Point there. And this is the same, had the same unit. So because of mass multiplied to velocity is equals to momentum, and momentum has this. Sorry for the short delay because my phone is slow bad and I have to charge it in the kitchen. So now to continue, mass times velocity is momentum, so we are going to find the final velocity after the collision of the bowling pin. So final velocity of this is still question mark. So now solve it. Solve. So going to transpose this one here because they have the same unit. So 10 negative plus 15 is equals to 1.5 VF, small because it is a something. So now solve it, this one. So the sum of this is 5, as you can see, and should be, and 1.5 copy. And now to know the final velocity of the bowling pin after the collision, so I'm going to divide it both by 1.5 because I'm going to remove this. I have to, so 1.5. So cancel because they have the same unit, so and you have to divide it, so 1, so it is, so now you have this velocity final, the velocity final, and now we have to divide this. So 5 divided by 1.5 is equals to 3.33. Now there you have the final velocity of the bowling pin. So its unit is 3.33 meters per second equals to velocity final. That is how you should write it. Yeah, this is the final answer. So the bowling pin go or it flew away because the bowling ball hits it. So its velocity is 3.33 meters per second. And that is how you get the conservation of linear momentum. If you're finding the final velocity for that one, for the bowling pin. So now, and that's the end of our session now. This is Landis Aldrich Mass reporting for conservation of linear momentum.